So this will be an example showing how to do a two-sample independent T confidence interval on some data. So we do need some data, so let's put in some data. This is about oxygen levels above a town and below the town. So we'll call above the first variable. And the data for above the town is 4.8, 5.2, 5.0, 4.9, and 5.1. And below the town is 5.0, 4.7, 4.9, 4.8, and 4.9. If you would like to make sure your assumptions are correct, you can do a histogram of both of these. So you could do a histogram of above. With only 5 data points, this won't be very telling, but what you can see is it looks kind of skewed. But 5 data points isn't going to tell you a whole lot. We can then do a Q norm, a normal quantile plot, and see what that looks like. This looks fairly linear, so that kind of indicates that yes, the population is normally distributed. And then you can look at a box plot of the data. I happen to like mine to be horizontal, but let's just go ahead and look at vertical, because all we care about is how many outliers there are, and there are no outliers in this because there's no dots above or below the lines. So, looks like we can probably say, even though the histogram was kind of weird, the normal quantile plot and the box plot look good, so we can probably say that that data comes from a population that is normally distributed. We'll do the exact same thing for below. Again, with 5 data points, your histogram is not going to be very telling, not going to give you a lot of information. So let's look at the normal quantile plot for below. And that looks fairly linear. So you can actually think about drawing a line that goes through most of this data and all kind of falls along the line. So that gives me a good indication. And then the box plot, again, to look at the number of outliers. And looking at this box plot, there are no outliers. So we can go ahead and say that that population looks like it might also be normally distributed. So now we're ready to actually do the calculations for the confidence interval. This is a T because it deals with means, and it is T.test is what we put into R. Anything that you're doing in R, you do a whatever dot test, depending on what kind of distribution you're dealing with. We'll put above, then below, and then this one has a confidence level equal to 0.9, 90%. And here's our information, and right here it says 90% confidence interval, and there's your information. So your confidence interval goes from negative 0.02 to 0.30. So this kind of tells me that the oxygen level above the town to below the town is anywhere from less by 0.02 to greater by 0.30 than below the town. So that really doesn't tell us anything because 0 is actually in that interval. So you can't say there's a difference.